So good morning, everyone. Thanks for coming for our second day of the RISE camp. And today we are going to hear about three other systems, PyWren, Opaque, and Wave. The last two are security. It will be focused on security. The first one, PyWren, is how to make it easy as possible for scientists to use large-scale computation. Also, I like to say one more thing. Please try as much as possible to interact with students, faculty here. This is not only one-way street in which we are just presenting some systems and provide tutorials. Please let us know challenges you have, suggestions about what to do, what we don't do, what things are more important to you. And ultimately, I really hope that this will be an environment which will foster more collaboration at all levels, from developing systems together to solving problems and developing application together. Thank you. And now, without further ado, let me introduce Chia-Che, who is going to give you more information about today's tutorials and today's schedule. Thank you.
Thank you. I'm Chia-Che. I will be your coordinator today. So first of all, congratulations. You have survived the first day. And so the second day of the RISE camp will be focused on data analytics systems and security. So the first session will be about PyWren, which is a system for elastic data analytics with serverless computing, which will be followed by the PyWren tutorial. And then we'll have the break, and next we'll talk about Opaque, which is a system for secure analytics on Spark SQL, protected with hardware enclaves. And this will be, of course, will be followed by the Opaque tutorial. And then we'll have a lunch break, and after lunch at 2 p.m. we'll start the Wave talk, which is a system for decentralized authorization for IoT devices. And this will be followed by the Wave tutorial. And finally, at the end of this day, we will have an integration tutorial that put a lot of the things you learned so far together to build a secure, machine learning-driven pawn game. So make sure you stay until the end of the day. This is the most interesting part. So let's start with an overview of all the talk today. The first talk will be about PyWren, which is to do elastic data analytics. So PyWren is basically a system to allow you to program applications that immediately go to the cloud and run in an elastic serverless way, and using services like AWS Lambda, Google Cloud Functions, and Azure Functions. And one of the big advantage is elastic, so you can easily spread out your execution to more than 5,000 core in less than 1 second. So very powerful. It's also designed for ease of use, so you can avoid all the expensive costs of setting up the cloud cluster, and all you have to do is write a simple Python program. It's also very cost efficient. It allows you to disaggregate resources and also increase utilization of the cloud resources, so you don't have to pay for keeping all these servers on all the time. And finally, we're targeting more and more function and use cases. One of the very good example is now it supports scientific computation with an extension called non-PyWren, and which is basically implement in a kind of NumPy way that everybody was pretty familiar with. And so the PyWren project now is open source. You can get it online. I was told that today they might announce the release of the new version, so make sure you wait for that. So they're also working on building a more capable runtime, which includes various packages by default, including NumPy, NumPy, pillows, and scikit-learn, etc. So this will be a very powerful addition to the system. NumPyWren paper, as I just mentioned, is recently published, and code release is on the way, so they're working on it. And so in the PyWren tutorial, you'll learn about a few things. First, you'll learn about how to program with PyWren API to write this program in Python, and how to deploy into the cloud to run as cloud functions. You also learn about how to visualize these execution statistics and how can you debug these executions with loggings provided by PyWren. And then we also demonstrate with several real-world examples, including a large-scale matrix computations and hyperparameters optimization for machine learning, and data analytics in Wikipedia. So you can pick one of these tutorial and play with it. Next, we'll talk about Opaque, which is a system for secure analytics with hardware enclave. So hardware enclave is the new technology provided by a lot of CPU, especially Intel SGXs, AMD SEV. And what it's providing is basically an environment to run your secured programs on top of untrusted platforms. So you can run things and defend it against attack vectors like malicious operating systems or administrators. And so what Opaques do is basically allows you to run opaque operators that do SQL operations like filter, project, joins on top of untrusted Spark SQL. And so first is providing is the trust execution. It can protect sensitive data from compromised hosts. Second, it can do encrypted distributed analytics. It basically runs on an untrusted Spark SQL, which can scale out to many machines with data both encrypted at rest and at transfer. Finally, it's also targeting oblivious computation, so that means it will hide the access patterns from for the operator running inside the enclave, so the attacker will be able to steal the information from side channel attack. So the Opaque Status is, of course, is open source, and so you can definitely go download it and play with it. Now currently support Spark Data Frames API with Scala, so you have to program in Scala. But it has been collaborating with IBM, including end-to-end deployment for two major use cases in IBM Cloud. IBM also contributes source codes, and also recently they pushed for main changes for PyWren that's widely adopted, mainly for Opaque. There's also ongoing collaborations with Ericsson, and Alibaba Cloud also recently announced collaborations with Opaque. So in the Opaque tutorial, you will learn about, first, how do you encrypt Spark data frames with Opaque API? And then with this encrypted data, how do you query them inside a hardware enclave so nothing inside the cloud provider will be able to see your secret data? And of course, this is running in SGXs, but this will need the actual SGX hardware, so we're running everything in simulated mode. But you can expect this exactly the same as running on a real SGX machine. And finally, you can also explain query plan that's created by Opaque. Okay, so the third system we'll talk about today will be Wave, which is a system for decentralized authorization for Internet of Things systems. And so inside Internet of Things, you'll have multiple entities, including devices and people who need access to these devices. And so what Wave providing you is first a decentralized trust. You don't need a centralized server to control these authorizations because the centralized server can be compromised. We prefer to run it in a decentralized manner. The second thing is you can also generate proof of permissions and give it to the people you want to trust. And these proof of permissions is basically cryptographically protected, and you can grant permissions to other entities. Finally, as proof of permission is basically tamper resistant, so user cannot forge permissions to any entity, and so they cannot fake another user that basically gain access to your devices or your home. So the Wave status is currently under publication. So its link will be available in the anonymized paper, so it will be available soon. But for Wave project itself, it has been operated for about 2 years in more than 200 houses across the states, controlling more than 800 devices, including thermostats, motion sensor, etc. So it has been showing quite a good example of how to run it in those IoT environments. So inside the Wave tutorial, you will learn about how to create identity to represent entities. So we will show basically a house with all these kind of devices where you can control. You can generate proof of permissions for authorization and given to another users. You can also verify proof that was given by another party, and so you allow them to control your devices. And then you will be able to authorize interactive permissions between namespaces, such as connecting two devices in two different homes. Finally, at the end of the day, we'll talk about integration. So far, you have to learn about several systems, both inside either AI systems or data analytics or security. And so, for example, you have learned about Ray and RLLib, which is for distributed reinforcement learning. You also learn about Clipper, which is give you low latency online prediction serving. You also learn about Flor, it's for machine learning context tracking. And finally, today you will learn about Wave, which is for decentralized authorizations. And today, our last tutorial will be putting all these 4 projects together, and basically that you create a pawn games. Inside these pawn games, we'll use all these systems to improve them. First, you will be training reinforcement learning policy using Ray and RLLib. And you also deploy the models and test them with Clipper. And then you will be able to track the training process with Flor. And finally, you will use Wave to authorize and encrypt those training models, so only you can access these very precious sensitive models. So what you can expect today is basically there will be a lot of deep dive into various parts of Rice Lab stack. You'll be able to see how other kind of projects that's going on inside Rice Lab. You're able to learn from firsthand experience from these leading students or postdoc researcher. You also be able to put everything you've learned so far to very good use. Also see how everything like these kind of projects will fit together in an integrated project. Make sure you should familiarize yourself with suggested reading. So there's for 2 systems today, they need to have some knowledge before you go into this tutorial. For example, for Wave, you need to know about public key infrastructure. And for Opaque, it will not be programmed in Python. It has to be programmed in Scala. So if you are not familiar with Scala, you should go read it. These just reading are all in the website. So make sure you read it before the tutorial starts. And finally, if you happen to find one of the project really interesting or happen to address your problem in your company, make sure you talk to the team during the break or find them during the lunch. I'm sure they will be very happy to discuss all these collaborations. And finally, enjoy hacking and enjoy learning. Thank you.